Hello everyone, welcome to my channel Ankeecodeverse. Today topic is about the understanding the role of protocols in Swift. A protocols in Swift is a blueprint of method, property and other requirements that suit a particular task or piece of functionality. It defines a set of methods, property and other requirements that a class, struct and enumerations can then adopt. When a class, struct and enum conform to a protocol, it guarantees that it implements the required properties and methods specified in the protocol. It allows all the implementations of multiple inheritance like behavior in Swift as a class, struct, and enum can conform to multiple protocols. How we work with protocols. Defining a protocols, protocol properties, protocol methods, protocol adoption, protocol inheritance, protocol extension, optional protocol requirements, checking for protocol conformance, delegations, protocol composition. Defining a protocol. You can define a protocol using a protocol keyword followed by the protocol names. You can see the example here. Protocol properties. You can define properties that must be implemented by any class, struct, and enum that adopt the protocol. You can specify whether the property should be a gettable or gettable and settable. Protocol methods. You can define methods that must be implemented by any classes, struct, and enum that adopt the protocol. You can see the example of below. Protocol adoption. A class, struct, or enum can adopt a protocol by including the protocol name after the type's name, separated by the colon. You can see the example of below. Protocol inheritance. Protocol can inherit one or more other protocols similar to classes. This can be done using the comma to separate multiple protocols. You can see the example of below. Protocol extension. You can provide a default implementations for any method or computed properties requirement of a protocol. For example, extension some protocol and create a function of some method and default implementations goes under the function. Optional protocol requirements. You can mark methods and properties with a protocol as optional, which means that adopting type don't have to implement them. You can see the example below them. Checking for protocol conformance. You can check whether an instance conforms to a protocol using the is and as question mark operators. If some instance is some protocols, you can declare the function under this condition. Delegation. Protocols are commonly used to implement the delegation design pattern, where one object acts on behalf of or in conditions with another object. Protocol composition. You can combine multiple protocols into a single requirement using the AND operator. You can see the example of protocols below them. How a protocol is defined. In this example, the sum protocol declares as a requirements of a variable some property of type int that must be both gettable and settable, as well as some method that must be implemented by any type conforming to these protocols. A class structure or enumerations can conform to these protocols. In this case, some class conform to some protocol by implementing both the some property and some method. How to use optional protocols. In Swift, the @objc attribute and the optional keyword can be used to conjunction with protocols to define optional requirements. The @objc attribute is used to make a protocol available of to Objective-C, and the optional keyword is used to mark protocol requirements as optional. Optional keyword is used to declare that the optional method is not a required part of the protocol. A class is conforming to the protocol can choosing to implement this method, but it is not mandatory. Advantage of protocols. Protocols offer several key advantages that contribute to return efficient, modular, and scalable code. Here are some specific advantages of using protocols: code reusability, polymorphism and flexibility, delicate design pattern, unit test and mocking, multiple inheritance like behavior, loose coupling and dependency injection, API design and contracts, Swift evaluation and generics. Code reusability protocol allow you to define a set of method and properties that can be adopted by multiple classes and structs, promoting code reuse across different parts of your application. Polymorphism and flexibility. By conforming to protocols, different type can be treated uniformly, allow for polymorphism. This promotes a more flexible and modular architecture and enable to use the different type interchangeably in various contexts. Delegate design pattern. Protocols are commonly used to implementing a delegate design pattern, enabling structured communication between objects and facilitating a clear separation of concern. Unit testing and mocking. By using protocol, you can easily create mock implementation for testing, allowing for effective unit testing and ensuring the correctness and stability of your code. Multiple inheritance like behavior. While Swift doesn't support multiple inheritance for classes, it does allow a type to conform to multiple protocols, providing a way to inherit functionality and multiple sources. Loose coupling and dependency injection. Protocols enable loose coupling between components, allowing for easier component substitutions and promoting better code maintainability and testability. API design and contracts protocol are using for defining clear interfaces and contract between different parts of your application, ensuring a consistent and predictable behavior for the components that conform to this protocol. Swift evaluation and generics protocol are a crucial part of the Swift language, and they play a significant role in the evolution of the language, especially the combination with features like generics, enhancing the compressive power of Swift and enabling powerful abstractions. Disadvantage of protocols. They also have some limitation and challenges. It's important to aware of these disadvantages when using protocol in Swift and iOS development. Complexity and indirection, overuse and proliferations, runtime performance, verbose syntax and boilerplate code, difficulty in debugging and tracing, limitation support for value type, complexity in protocol hierarchies. Complexity and indirection. Working with protocol can introduce additional layers in indirection and complexity that making it challenged to track the flow of data and behavior in the code base. Overuse and proliferation. Overusing protocol can lead to an excessive proliferation of a small protocol, which might complicate an understanding of the overall architecture to make the code base harder to manage. Runtime performance. Dynamic dispatch, which is commonly used with protocols, can introduce some overhead compared to static dispatch. This can potentially impact runtime performance, especially in performance critical section of the code. Verbose syntax and boilerplate code. Implementing protocol may lead to verbose syntax and need for the boilerplate code, especially when dealing with default implementation, optional requirements, and associated types. Difficulty in debugging and tracing. Debugging code that heavily relies on protocol might be more challenging as the relationship and interaction between different components can become intricate and less transparent. Limited support for value type. While Swift provides excellent support for value type, working with protocols, especially with associated types, can be more complex and less straightforward when dealing with the value types. Complexity in protocol hierarchies. Complex protocol hierarchies might introduce challenge in managing dependencies, especially when multiple protocols inherit from each other, potentially leading to a convoluted class hierarchies. An example where we have a protocol label that define a basic structure for any type that can be played will will be then create two types, audio player and video player, both of which conform to the playable protocol. Finally, we have demonstrated how this type can be used interchangeably in the array. Thanks for watching. Stay tuned for the upcoming video and don't forget to like, share, subscribe with your iOS group. Thank you.